Welcome to this video on Introduction to Functions. By the end of this video, you should be able to name an ordered pair, describe the difference between a discrete graph and a continuous graph, and identify the domain and range of a discrete or continuous relation using different representations. All right, so let's take a look at our first page of notes, where we're going to learn the definition of a coordinate plane. A coordinate plane is a plane that is divided into 4 regions, and we use it for graphing. So let's do a quick review on our coordinate plane. So here's our coordinate plane. It's divided into 4 sections, and the way we number them is this is called quadrant 1, and we use Roman numerals when we label them. This is quadrant 2, quadrant 3, and this is the 4th quadrant. Okay. Other important features of our coordinate plane is this point right in the very center. That is called the origin. When we're counting to plot our points, we always begin from the origin, and the origin is at 0, 0. This horizontal line with the arrows on it, that's our x-axis. And this vertical line through the origin with the arrows on it, that's our y-axis. Okay. Now, we're going to review quickly what an ordered pair is. An ordered pair is just a point, and the point is made up of the first number will be an x value, and the second number is a y value, and that's what we're going to put on a graph. So what we need to remember is when we're naming our ordered pair, if our x value is positive, that means we had to go right from the origin. If our x value is negative, that means we had to go left from the origin. If our y value is positive, that means we'll go up. And if our y value is negative, that means we'll go down. So you count left or right first for your x, and then up or down for your y. So let's name a few of these. They're already plotted for us, and so we're going to name them and say what quadrant they're in. So A, to get to A, we'd have to go 1, 2, 3 to the left, which would be -3. And then 1, 2, 3, 4 up, so that's a positive because we had to go up. So -3, 4, that is in the second quadrant. Let's try B. B is right here. So we're naming everything from our origin right there. So we had to go 2 to the right. And then to get to the point, we had to go down 1, 2, 3. And that's a y value. That's down. So that's a -3. B is in the 4th quadrant. Here we have C. To get to C from the origin, you don't have to go left or right at all. So for our x value, we're going to say 0 because there's no left or right. But we did have to go up 2 to get to it, so that's a +2. And when it's on the axes like that, it's not in any of the quadrants. We'll say where it's located. This is on the y-axis. Okay. Now, pause the video and come back, do the next 3 and come back to see how you did. All right, for our last 3, D was 7, 1 in the first quadrant, E was -4, -6 in the third quadrant, and F was -5, 0, and it was on the x-axis. All right, another point that I need to make sure that you understand is the difference between a discrete graph and a continuous graph. So a discrete graph is a graph of distinct points. And what I mean by that, it kind of looks like what we've got up here, is that there's exact points where we'd be able to name them. So an example that I've got my x and y axes listed here. So discrete points are just individual points that are on a graph. They're not connected together in any way. We could just name the individual points. And that's going to contrast with the idea of a continuous graph. So a continuous graph is going to be a graph that's connected with lines or curves. Okay, so I'm going to draw my example here. I'm going to do a curvy one. Okay, the idea behind this is there's so many points and they're so close together you can't see any individual point, that they're all, and that's what makes up the line. So we can't name the individual points as easily like we can with the discrete graph. So the continuous graph is all the points are so close together they're touching, making a continuous line or curve, and the discrete graph are individual points. All right, let's flip this over and talk about relations. So a relation is a set of ordered pairs. It's just any set of ordered pairs. So I have some examples of some ordered pairs here in your notes. It's called a relation. What we are going to want to do with this is we're going to want to be able to identify the domain and the range. So the set of all x values in a relation is called the domain, and the set of all y values in a relation is called the range. Okay, so we're going to pull out the domain and range from these points and we're going to list them separately from each other. But there is one thing I want to let you know before we do that. When we write our domain and range, we're going to want to write the values in order, smallest value to largest value. So let's take a look at what I mean. So the domain, remember, is an x value. So I only want the x values from these points, and I want to put them in order from smallest to largest. So we're going to open up a French scroll. That's for a set of numbers. Okay, and the very smallest x value is -3. Now -3 is used twice, so I've got a -3 here and a -3 right there. I'm only going to list it once. I don't need to list it 2 times. The next smallest x value is -2. The next is a 1, and then we have a +3. So all the x values represented in this relation are -3, -2, 1, and 3. Now for the range, remember the range is a y value. So we're just going to go and do the same thing. We're going to list the y values in order, smallest to largest. The smallest y values is -4, and then 0, 1, 2, and 5. So if I'd ask, what is the domain of this set of ordered pairs? The domain is these numbers. What is the range of those ordered pairs? I would list just the y values. Okay, so when we're looking at ordered pairs, this is how we can pull out our domain and range. We can write our ordered pairs into an XY table of values. So what's real important here is they need to remain matched together. So if I say if my x value is -3, the 1 has to stay with it because these are really the same thing. These are the points, just one's written as a coordinate point and the other's in an XY table of values. Okay, -2 will go with 0, 1 goes with 2, 3 with -4, and -3 with 5. Okay, so if we had a table of values, we could plot those points on a graph because these are just individual coordinate points. For our mapping, in our mapping, the left-hand oval is going to represent our domain, and the right-hand oval will be our range. So we can really just take our numbers that we used here. Our x values for our domain were -3, -2, 1, and 3. And my y values were -4, 0, 1, 2, and 5. Now what we want to do is, because these are points, we want to match them together. So when we see -3 goes with 1, so I'm just going to draw a line from -3 and say it goes with this value over here in the range, 1. -2 goes to the value in the range of 0. 1 goes with the value 2 in the range. 3 goes with -4, so all the way up to the top. And then -3, again, it's going to be used again, so it's going to match also with 5. Okay, so the lines are just saying for the coordinate point, this is who it's going to match with, but we've got our domain in one section and our range in the other. Finally, we're going to graph our points. So remember, our x and y tells us our left or our right. our X is our left, right, our Y is our up, down, and we always start with the X. We're counting from the origin. So this says go left 3, 1, 2, 3, and up 1. And that's where our first point's going to be. That says go left 2 and don't go up and down at all. So that's our next point. This says go right 1 and then up 2. This point is right 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. And our last point says go left 3 and up 5, 1, 2, 3, 1, 2, 3, 4, 5. Okay. What we're going to do is we're going to do the same thing with number 3 down here. Number 2 is exactly the same. So we're going to skip over it. But when I look here, there's no points. There's nothing to start with. There's no numbers. There's no numbers. But when I get over here, I actually have the points. So what we want to do is we want to name these points. We'll write them as ordered pairs. And then you can finish the mapping and the table of values. Okay, so I'm going to name this point first. It doesn't matter which one comes first right now. This point, to get there, I'd have to go left 2 and up 3. So left 2 and up 3. Okay. To name this point right here, I'd have to go left 1, 2, 3, 4, 5. So that's a -5. And then down 1, 2, 3, 4. So that would be -4. To name this point, from the origin, I don't have to go left or right at all. So it's going to be a 0 and then down 1, 2, 3, 0, -3. This point right here, I'd have to go right 2 and down 1, 2, 3, 4, 5. So right 2 and down 5. And for my very last point, right over here, I'd have to, from the origin, 1, 2, 3, 4, and up 2. So I'd have to go right 4 and up 2. Now, I'd like you to pause the video, pull out the domain and range. Remember, these are the X values for the domain, the Y value for the range. Just like we did in number 1, write them in the table of values, try the mapping, and come back to see how you did. All right, so let's take a look. For our domain, you should have -5, -2, 0, 2, 4 in that order, smallest to biggest. And our Y values, our range is -5, -4, -3, 2, and 3. For our table of values, you should have -5 matched with -4, -2 with 3, 0, -3, 2, -5, and 4, 2. Right? For our mapping, you should have our domain and range written in the same order as it was written over here originally. And then you're going to match -5 should go with -4, -2 with 3, 0 with -3, 2 with -5, and 4 with 2. All right, so hopefully that's a concept that you remember. Let's flip this over and talk about a special kind of relationship of relations called a function. So a function is a special relationship between values, and that relationship is for each input, which is an X value, there is exactly one output, that is a Y value. You can kind of think of a function in terms of like a soda machine. If you press the Coke button, you're expecting Coke to come out. So if you press Coke and Coke comes out, the machine is functioning. But if you push the same button, Coke, and you get Cherry Coke out, that's not what the input said that you needed to be getting out, and so that machine's not functioning. It had more than one output for the same button being pushed. Okay, so what that means is you want your X values not to repeat if it's going to be a function. Okay, so overall, that's really what we're kind of looking for here. So let's take a look at these first two examples to give you an idea. All right, so let's remember, when we're looking to determine if something is a function, the X values will not repeat because each input of X has exactly one output of Y. So we're really focusing on our x values here. So I have an x value of 10, 5, 7, and 11. None of those x values repeat, so that means this is a function. Okay, let's look at another example. In our next set of coordinate points, we're going to take a look at our x values. We have a -4, -1, 5, and another -1. So -1 and -1, your x values repeated. That makes it not a function. So your overall takeaway, look for repeating x's. If they repeat to different y's, then what we're looking at is not a function, it's just a relation. So we're going to look at problem number 1. Take a look at your x values, 5, 3, 2, 0, -1. None of those x values repeated, so this is a function. Just try it again with number 3. We have -4, -3, -2, 1, and -3 again. My -3 value for my x's repeated, so this is not a function. All right. So that's when we're looking at coordinate points. Look at the x values to see if they repeat. In our table of values, it's a little bit easier because we're just looking at this single column, just the x values. When I look down, 3, -1, 0, 2, 3, I notice that those two are the same, so this is not a function. Let's try it again with number 7. -5, -3, 0, 1, 2. None of these x values repeated. That makes this a function. One more time with the table of values on number 9. We have -8, -4, 0, 4, and 8. None of the x values repeat. They're opposites. One's positive, one's negative, but they'd have to be exactly the same x value, so this is a function. Right. For our mappings, remember when we were doing the mapping, we were drawing the arrow from the x to the y that would make its coordinate point. So what you're looking for here is for a value to have more than one, an x value to have more than one arrow coming off of it, meaning it was used in 2 different points. So when I look, each of these x values only has one arrow coming off of it. That makes this a function. Okay. If I look at number 12, -4 has one arrow, but you see how -1 has 2 separate arrows coming off of it? That means -1's being used twice, once with -1 and once with 7. So because the x value is being repeated, it is not a function. In number 13, take a look at your x values. They each only have one arrow coming off of them, so this is a function. All right, let's finish this out by learning about the vertical line test. The vertical line test states that if a vertical line intersects a graph more than once, then the graph is not a function. If a vertical line intersects a graph more than once, then the graph is not a function. So you may be told previously to use your pencil as kind of a vertical line to go back and forth to see if it crosses more than once. But I'm going to just draw some lines in to kind of help us see this. So I'm going to give us a line here, and we're going to determine if that line is a function. So I'm just going to draw a vertical line straight up and down. How many times does it cross the pink graph? It only crosses the pink graph once. If I draw it again, it only crosses the pink graph once. Every time I draw a vertical line, it's only crossing the pink graph one time. That means that this is a function, okay? But what if I had a circle as my graph? Okay, so I'm going to have a circle. If I draw a vertical line, you can see I cross the pink line here and here. This is not a function because if you name these 2 points, they both have the same x value, but they have different y values. So that it goes against what we were saying of what makes a function, is that the x value can only have one output, but this has two different outputs for the same x value. So that is not a function because you're crossing the x twice. You're using the same x value more than one time. So let's take a look at each of these. So let's look at our first graph on number 15 is the one I want to do. So I'm going to draw, when they're discrete points like this, I'm just going to look at the line they're on and see if I go through more than one discrete point at a time. I only go through one discrete point there. If I draw another one, that's only one discrete point that I went through. I only went through one discrete point here, and here, and here. None of those had lines, points lined up over each other, so this is a function. Okay. Let's take a look at number 17. If I draw a vertical line, we can see right away that I cross the graph twice, here and here. Those x values are the same x values with two different y values, so this is not a function. Take a look at number 19. I can just check a whole bunch of vertical lines, and I'm seeing I'm only ever hitting the graph one time on each of those vertical lines, so this is a function. And for our last one that I want to do with you today, 21, same thing. Check your vertical lines. It's only ever hitting the graph one time as it goes through, so this last one is also a function. You're going to go back and finish all the even problems from these notes to put into Canvas. Let me know if you have any questions. See you in class.